Hello friends, in this lab we are going to configure Palo Alto Firewall along with the gateway load balancer. So here we are going to take VPC with internet gateway and public subnet for jump host creation and private subnet, so it's for test PC, and another private subnet for gateway load balancer. This private subnet for gateway load balancer endpoint, and another private subnet and public subnets for our VM, Palo Alto VM, and it is for network gateway, NAT gateway here. So I will explain you the traffic flow here. First, we are going to take jump host. We'll log in into the jump host, and from there we'll log in into this test PC because we are not providing any internet connectivity for this test PC. So, but from this PC, if you want to reach internet, it should pass through the firewall from the gateway load balancer and the firewall. Then it should pass through the network NAT gateway and it should go to the internet. So that is our plan here. So once the traffic initiated, first it will hit the gateway load balancer endpoint, then it will go to gateway load balancer. Gateway load balancer will pass the traffic to firewall. So after inspection done by the firewall, it will come to gateway load balancer, then it will go to gateway load balancer endpoint, then it will reach the NAT gateway. After that, it will reach the internet. This is overall traffic flow. So let's get started. Here a few steps I noted down to create our lab VPC creations. After that, we'll create internet gateway, subnet creations, and route tables and associated with the respective subnets. Then we'll launch the Palo Alto instance. Then we'll create target group for gateway load balancer. Then we'll create gateway load balancer and attach that target group to respective load balancer. Then we'll create a endpoint service for this gateway load balancer. Then we'll create endpoint and we'll associate with this service. Then we'll create a subnet creation. We'll do the subnet creation and association with the sub interfaces. This is on the Palo Alto firewall. So we create as well as we create jump host. Then we'll test PC and routing modification according to this routing. Then we'll test and we'll see if there are any issue. We'll do the troubleshooting. So let's jump into the lab now. So this is my VPC management console in AWS. So let's start with VPC creation. Create VPC, Palo Lab VPC. Just I am selecting this network 10.10.0.0/16. Create VPC. So VPC creation is done. We can see here. Let me create internet gateway and attach to this VPC. Internet gateway 1. So internet gateway is created, but it is not attached to any VPC. Let me attach to our Palo VPC now. Palo Lab VPC. Attach internet gateway. So now it is attached to VPC. So let's start subnets creation. We have a total 7 subnets here. Let me create one by one. Under this Palo Lab VPC, let me create one subnet for jump host. Jump host subnet. And let me create it in US East 1A region. Sorry, 1A zone. It's a zone details. Then let me create it 1.0/24. The name is jump host subnet. Create another one. app VPC, test PC subnet. I'm going to create all are in same zone. 10.10.2.0/24, and directly from here we can add one more subnet. Let me create from here itself. GWLB gateway load balancer subnet it is. Zone 10.10.3.0/24. Let me add one more subnet. 10 dot. So here is the name is for GWLB endpoint. This is for gateway load balancer endpoint. Here we have given 3 and here it is 4. 10.10.0. Sorry, 4.0/24. Let me add another subnet. And here it is for firewall data. Should be in the same zone. 10.10.5.0/24. Here we have given 4 and it is 5. I think we have created total 5 subnets we have created now. I think 4 subnets. Yeah, we have created 5 subnets. Let me clear this filter. Let me create the rest of the 2 also. So firewall M and G for management subnet. It should be in the same zone. 10.10.6.0/24. Let me add NAT gateway subnet as well. NAT gateway subnet. It will be in the same zone. 10.10.7.0/24. Create. So total we have created 7 subnets here. Test PC subnet, NAT subnet, firewall data subnet, gateway load balancer subnet, firewall management subnet, jump host, and gateway load balancer endpoint subnet. So our subnet creation is done. So let's start routing tables creation. So here already one root table is there. This is for VPC, which we have created only, but it will be created by default. But I don't want to use this subnet now. Let me save it as a default or main root table. So this is main root table. So let me create other roots table and will associate with the respective subnets. Let me name it as jump host root table. Or let me simple put root table RT. Create. So first let me create all the root tables, then we'll associate one by one. So jump host got created. This is for test PC. RT, I think my root table here. Create. And this is for GWLB RT, the same VPC we have to select here. Created. Let me go back there and create other root tables as well. GWLB. So let me mention some cab and put this. This refers to endpoint. So select this respective VPC here, and we have created 1, 2, 3, 4 root tables. Rest of the 3 also we are going to create now. This is for firewall data RT, firewall MNG management RT routing table. So only one left, that is for NAT gateway. Let me create NAT gateway one also, NAT RT. Perfect. So we have created all the root tables. So we have created 7 root tables. So VPC creation is done, internet gateway configuration is done. Let me go back to these details. VP creation is completed now, internet gateway creation done, subnet creation also completed, and we have created routing tables, root tables, but let's associate these with the respective subnets. Let's go back to this root table. First, let me select with firewall, subnet association. Here you can see edit subnet association. Go there, and this is for firewall data, save association. So here you can check the details, which subnet is associated with this route table. So let's go to management, firewall management route table, edit subnet association. We can associate this firewall management. So it got associated. Gateway load balancer subnet, subnet association, edit subnet association, gateway load balancer subnet associate. Then go back to another one, gateway load balancer endpoint subnet. Let me get the association for this, endpoint subnet, save association. So for jump host association, edit association, this is for jump host, save subnet association. Then NAT route table subnet association, edit subnet association, NAT subnet, save association. Then the last one, test PC subnet association, edit subnet association, then select this one, test PC subnet. Here we go. We are done with the associations. So now we can see all the subnets are associated with the respective routing tables here. So for example, if you see NAT gateway, it should have those respective routes. In all the routing tables, currently we have only default route, that is local one. This is VPC related route. So in all the routing tables, we have only default route now. But as per our requirement, we have to add rules in this route table. Okay. For now, so let me go to public routing tables, and for public routing tables, we should have a route towards internet gateway. So there we are going to add routes towards internet gateway. So let me open our lab topology once. So here we have a 3 public subnets. So we should have a route from these subnets towards internet gateway. So from the jump host and from the NAT gateway and also from the firewall management subnet. So let's create that routing table now. Let's jump into lab and firewall management route table. Let me select this routes, edit routes, add route 000 towards IGW internet gateway, save changes. Now go to NAT route table, routes, edit routes, add route, default route 000, select internet gateway, select the created one, save changes. So it is good. Then go back to the route tables and we have one more public subnet that is for jump host. So let's select the jump host. Now routes, edit routes, create default route towards internet gateway. So this part is done. Let's go back to our checklist. So VPC creation is done, gateway subnet creation up to here we have done. Even we have modified the routing tables a little bit. So and now we are going to create Palo Alto VM instance launch. So let's get started. So let me go to EC2 instances, click on launch instance, firewall, Palo Alto 1. So let me search for Palo Alto AMI. It will be available in AWS Marketplace. So let me select this firewall bundle 1. Click on continue. So these are all AMI details and this is instance type. This is sufficient for our lab test. And let me create key pair and assign it to this instance. So Palo Alto lab key. Let me take it in putty, create key. So attach it to this instance. And here we are going to select respective subnet. So VPC is correct, but the subnet we are going to select firewall data subnet because later we are going to swap this interface to data subnet only because here we are going to use gateway load balancer. Gateway load balancer only sends traffic to ETH0, but the firewall instance launch with the ETH0 only, and that is useful for management subnet here, management interface. So that is the reason we attach it as a management, but will swap it towards data. So that's the reason I'm directly selecting data subnet and we'll create it, but we'll swap it again. Okay. So for data subnet, there is no need of public IP. For management interface only, we require public IP. So let it be. We can keep as is. And let me create new security group here. This is for data. So firewall data. Just I can give the command as data only. And here we required only the traffic. So let me mention that particular traffic which is required here. So SSH can be there, but let me put it as, so along with these details, let me add one more thing that should be there to allow this gateway load balancer traffic. So that is for GNU protocol 6081 is the GNU protocol port number 6081. That is UDP traffic. Custom range, it can be any IP for testing. And let me add one more rule here, that is for TCP for health check. Later we'll use this, but let me add and I will show you later. We will use this custom TCP and port number 80. Go to advanced details. Here directly we'll swap the interface using bootstrap commands using user data. So let me go there. This is the command to swap the management interface. So rest of all good. So click on launch instance. Launching instance now. So meanwhile, let me go to interfaces and create interface, secondary interface that will be useful to us for management purpose. Firewall mng int interface. Let's create this in management subnet. Private IP assign. So let me use this security. Let me use this one for present. So this is for management, just now we have created, and this is for data. So we have created two interfaces, but we have assigned the same security group. So let me change this management security group. Actually, we don't require all these 6081 and the 80 on that particular group. So let me try to change it. Change security group. Here there are no other security groups, so let me create it first, and then we can assign it to particular interface. Security groups. Already for data we have created one. This is for data NSG. Firewall data NSG. Save. I'm going to create other security group. Firewall MNG NSG, management security group. Under this same VPC, and add inbound rules. So we should be able to access this using HTTP and HTTPS. Anywhere IPv4, and let me add SSH. IPv4. Let me add HTTP also. anywhere, and let me add ICMP IPv4 just to test ping. So these are all created. Let me click on create security group, description, allow management access. So just click on create security group. It's going to create now. Let me go back to interfaces. Let's assign this security group to management interface first. Actions, change security group, remove, firewall management NSG, add security group, save. Perfect. Now data interface is in data security group and management interface in. But we have created but not attached to this VM. Let me attach this interface to our instance. Attach instance, attach. Perfect. And also we should be able to access this using public IP, but we haven't attached any public IP for these interfaces. Both are in private IP addresses only. Let me attach public IP address for this management interface. So let's go to elastic IP address and create one. Tag firewall IP, create, got created, and here is the IP. Let me attach this to associated IP address with interface. That is our management interface, and this is private IP address. This is the public one. Okay. All right. So we have attached this to our instance. Let's check that our instance is up or not. So we can see two IP addresses. Let's go back. Let's just check this networking tab. Under this, we can see two interfaces. This is for management interface. So all good. Let me copy this IP. Let's test this communication now. HTTPS colon IP address. So let me take command prompt, ping, paste IP address. Let's see. So still it is not pinging. Maybe there is still it is booting up. Let's go back to instances and check the status now. Instance state, actions, monitor, get instance screenshot. So I think yes, it is still booting up. Almost done, I think. So let's go back to instances. Just reload it. Let me ping this IP again. Yeah, it started responding. Now it is. We are able to ping this public IP now. Let me refresh this page. So we need to log in using putty first. Browse that SSH key which we have downloaded before. Open. I think it is responding to ping, but it is not yet ready for management. So let's wait for some more time. Okay, let me try one more time. Still the GUI is showing same page, but let me go back to putty and try the same again. Browse, SSH key, paste the IP address, open. Yeah, this time I can see some alert, accept. So let me enter credentials, admin. Okay, I think still it is trying to do something. Let me close this and retry again. If it is not ready, generally it shows like refusing. Open, admin, click on enter. Yep, now it is accepted, I think. Oh, the session got crashed. Anyway, let me try one more time. As it is in booting process, so it is behaving like that. So anyway, let me try one more time. Admin. Yep, this time it looks good. And yeah, let me configure the IP address for this admin so that we can access this through GUI. So configure set management config user admin space password. Let me give some strong password here. All right, so let me do commit. So once it is committed, we should be able to access through GUI anyhow. So login page should be load now. Yeah, advanced, click on proceed. So once it is loaded with the login page, let's try with our password. Go back to putty session. Let's check the progress here. It's almost done. So once it is finished, we can use this credential to log into Palo Alto GUI. So it's almost done. So yeah, commit is completed now. Let me try that newly created password. I enter this. I think seems like it is accepting. Yeah, everything seems good now. So as of now, we have created Palo Automation and we are able to log in into the device using this public IP address. So this is our Palo Alto GUI. So it looks good. Everything is cool. So we can see just now it got launched. 0 days, 13 minutes. So everything is fine as of now. Let's jump into the next part. So up to here, everything is good. So we have completed this part now. So let's start with the target group now. Let me go to the device, EC2 instances, this target group to associate with this load balancer. So let me start with the target group first. So create target group. This is for instances. Palo Alto Firewalls target group. Let me give this as a name. And here we have to select GNU protocol. So if you would like to know more details about GNU protocol, we have a lot of docs in AWS as well as Panorama. Palo Alto KB, so you can refer that. So we must use GNU protocol, so it will be understand by Palo Alto machine. So it uses to communicate, to send the data, anything it will use 6081 port only. That is the reason in previously we have allowed that 6081 port in network security groups. Okay, so that is the reason we have to allow under data. We have allowed this 6081 port. Let me show you that. This is the one for this communication. Okay, so let me go back to this VPC, Palo Alto VPC only. TCP, that is fine. Just okay, it is not accepting this much long. Just firewall target group, that is fine. Next, it got created. Let me click. Actually, it is showing this firewall details, firewall Palo Alto 1 details. So let me click and include as a pending. It's accepted now. Then go back to load balancers page, then create a gateway load balancer now. Click on create. GWLB 1, just a name. And VPC is Palo Lab VPC. Here we have to select this zone, the same zone I'm selecting. And for this one, we have created subnet. Let me put it here. Listeners, here we have to select the group which we have created just now. All right. Let me go back to the groups and check. Okay, I think we did not save it. Let me create one more time. Create group, instances, firewall, target group. Select GNU protocol. VPC is this VPC only. Next. Here we have to select this, include as pinning as below. Then click on create target group. So I think it got created now. So no load balancer associated with this. Let me go back to the load balancers. Try to create it again. Gateway load balancer. GWLB 1 VB4 interface VPC ID, and yeah, this should be in GWLB subnet. Yeah, there it is reflected now. Just click on create. Okay, it is not accepting. Let me put SS. Fine, it got created now, I think. Let me go back to the load balancers and see the status. It is showing us still in provisioning. So let me refresh it. and see what's going on here. Yeah, it is active now. So let me check this. Open this and let's check the status of these target groups. Yeah, it is showing in initial state. Let's refresh. Initial health checks in progress. Here we can see it is in initial state now. Let's see if it has failed. We need to go back there and check some settings. Yeah, so one more thing. So here just we configured this one to check 6081 and it is using port number 80. Let me show you that. Target group attributes, health checks. Here it is using port number 80 in the TCP protocol. So we have to configure this on management interface, I mean data interface, which is continuously checking from the gateway load balancer. So once it is okay, then it will show up here, show healthy here. So let's go back to targets. I will show you it will fail definitely. Anyhow, let me go back to firewall and we'll configure the things now. Palo Alto Firewall, network. Let me assign this interfaces. Interface configuration, layer 3, config. Just I'm using default router. Zone, just I'm creating H health chk health check, nothing but just I'm creating this. Click on OK. This is fine. Go to advanced mode and here IPv4, just select the DHCP client and go to advanced. Just select network profile. Here we have to configure these two things for health check. Health check configuration, click on OK. Click on OK and commit the things. If we pause the video, once it is committed, I will resume that. So it is committed successfully. Let me go back to the target groups. Still it's showing unhealthy. Just now it came up, I think. So let's recheck. Yes, now it is healthy. So target group, we have assigned only one device now for testing. We can like this, we can assign multiple firewalls. We can configure like this, but as a total targets are one only as of now. So now it is healthy. Here you can see the status. Okay, so let's go back to our menu. Here gateway load balancer has been created now. Let's create endpoint services and endpoint creations, and we'll associate subnets and all. So let's go back to here, endpoint creation. Let's go to VPC management console. Here it is endpoint services. Create endpoint service, GWLB service, endpoint service. It is gateway, and here we have to select the gateway details and acceptance NAST required. As this is a test, in real time we can enable it. So create. So service has been created now. Let me go back to the get point endpoints, and I will create endpoint here. GWLB endpoint. So this is other services comes under. So let me copy the service name from there. Endpoint service. Need to copy this service ID. Go back to this endpoint creation again. Endpoint, paste here and verify. So let me open a duplicate and let me see. I think we have to take service detail, service name. So let me go back to this EC VPC and endpoint services. Select this, and here is the service name. We have to copy this, go back to here, and just paste on this verified service. So service is verified. Let me select a VPC. VPC is Palo Lab VPC only. Subnet, we have created one subnet here already. So let me select gateway load balance endpoint subnet here. Create endpoint. So everything is fine. So as of now, we have created up to here. Let me associate with these interfaces, firewall interfaces, then we'll create jumpy host as well as test host, then we'll do some modifications in the routings, then we'll check this. So let me create sub interfaces. Just click on add sub interface. Test 1.1 data. And IPv4 DHCP client advanced. There is nothing is configured, so let's just create it. And I think we need to change this routing zone. Let's create a data zone. Click on OK. The routing is same virtual router. Let's use the default one. So everything is good. Let me associate this endpoint with this sub interface now. Go back to this and let me enable. We need to enable this plugin first, GWLB and plugin. So let me do this. Inspect enable. Then we can check this debug show interface, show plugins interface. If you can see here it shows some details. It is enabled, but no VPC endpoints with the interfaces. So let me do that. So let me copy endpoint ID. This is just endpoint. Copy this endpoint ID and take it in our command. And interface details already edited. So let me take this and paste over here. Hit enter. So let's check once it is up. Let's check the details here. Did we come back to the firewall and commit it? Did this changes and sub interface, but it is not committed it. So that's why it's not working. Let me click on commit. So commit successful now. Let's go back to our interfaces and check the details. Yeah, here it is showing the VPC endpoint details. Here all are comes under intra zone only, where so the health check is configured under same zone. So if you go back to the interfaces, so this is under health check zone. So security zone is health check. So health check to health check, it is already working because already there is a default role which is allowing intra-zone communication. But let me quickly create another one so that we'll have an idea how it is working. So this is for health check. This is for health check. Source, just let me give as any destination as any just for action allow, and we can see the logs if we tick mark here. So just to get the logs, I'm enabling it, and even you can mention the source IPs and destination IPs, but in this case I'm not going to do that. So just I'm allowing any traffic. On top of that, let's we'll create another rule. So let me commit it. Yeah, it got committed. So actually we can enable monitoring, I mean login section here also by overriding this, but just I have created separate rule just to check the logs so that we can get some logs and we can do what exactly happening here. Okay, so let's start our jump host and the PC test PC creation. So this is my EC2 console launch instance. This is for test PC. Just I'm using Microsoft Windows and key pair is same which I have created earlier. And just let me edit this PC lab test PC. This is perfect. No public IP is required here. Just I'm using this default one. So basically it allows RDP. So let me create new one, test PC NSG network security group. So it allows RDP from our from anywhere. Basically it is from our we do it from the jump host, so let it be, no problem. So here I'm going to create, as this is a lab, just I'm allowing any, but in real time we should allow this specific subnet. So but here I'm allowing any subnet as this is a test. And let me add a few more rules. Just ping allow ICMP all from anywhere. Anyhow, this is having only private IP, so no issues. Here we are disabling this. So perfect, everything is good. We're creating it in test subnet, right? Okay, perfect. Click on launch instance. Got launch now. Let me go back and create jump host as well. Instances, launch instance. Jump host. Select the key pair. and here RDP required from anywhere. So this is, let me edit this. This should be in jump host. So public IP should be enabled. Jump NSG. So let me give anywhere RDP, and let me add hello ICMP all from anywhere. That's fine. Just branch instance. Let's go back to instances and check the details now. So test PC got created now. So we have some IPs, private IP only. So jump host is still pending. Let me check this. So jump host is ready now with the public IP. So let me just click on connect, and here we should see this RDP client, and here we should get the password. So to get the password, so just I need to click on get password, and we need to upload our key here. So I uploaded the key and I got the password now. Let me store it here in the notepad. This is IP address for RDP session. Anyhow, actually earlier I have downloaded putty key, so I was able to actually I need to change this to PEM key. So I did it. Basically, I did it like this, load it from here, and there is an option to export open SSH key, because earlier we have downloaded normal putty key. So this is for putty key. So I generated this PEM file now by using putty generator, just for your information. So this is fine now. So like this we can generate and do this. So this is for to log in into this jump host, as well as let me get username and password for other PC also, for private PC. Let me go back to this private instance. So here we have saved this for public. Go back to instances, test PC, connect, RDP. Sorry. So get password. Just upload private key, decrypt. So this is for test PC password, and yeah, let me take this a notepad, and this is for public jump host. So let me go back to this public jump host, and let's connect to that by using RDP session. Jump host connect. Directly we can do it from MS RDP here. Otherwise we can simply download this file and we can click on it. Let's go back to there. Let me enter this public password. Okay, so it is getting connected now. So everything seems good. It's loading now. So let me pause this video. So once it is completely up, I will resume this session again. So this is our jump host. Just I created a test file for testing. So anyhow, so let me do RDP from here to our private host, test PC. So just come here and click on RDP. Remote desktop protocol. Just open this app. In jump host, I'm doing this. So just enter the private IP address. Click on connect. So admin administrator. The password is this one, which we have saved earlier. Pasted. Oh, this is fine. Click on OK. Yep, here we go. So here we are able to connect this PC from the jump host. So let me pause this video. Once it is up, I will resume it again. So this is our private host test PC, and this is our main jump host. Here you can clearly see the details. So this is our test PC. Let me browse something from the test PC now. So open Chrome. Yeah, just on the test PC, I opened command prompt. Let me ping 8.8.8. So if you see, it is not reachable. So there is no way to reach internet. So let me ping google.com here. So it is also not working. So because we did not add any routes towards this internet. So let's do that now. So this is our basic topology. So let me show you first what's exactly happening here. So here we are using jump host to log into the test PC as because we don't have a direct internet connection. And from here, so we should route all the default traffic to gateway load balance endpoint. Here and from here, once it is hit the traffic on gateway load balancer endpoint, directly it will hit to the load balancer, and already we associated this with this Palo Alto, so it will go there and come back to the gateway load balancer endpoint. So in return traffic, it will check this routing table, so which is hosted in private subnet endpoint. It will check the routing table. So there we have to configure this routing table towards NAT gateway. So already on NAT gateway we have configured default route towards internet. Okay, let's do that now. So let's go to route tables, go back to test PC, routes, edit 000 towards gateway load balancer endpoint, save changes. Then go back to endpoint, endpoint route table, then add default route towards internet gateway. Sorry, gateway, NAT gateway here. Okay, so here is the thing. We did not create NAT gateway yet, just we have created subnet, right? So let me go back there and create NAT gateway. Creating NAT gateway here. Then subnet, public, and here it required public IP address to communicate with this internet. Just I'm clicking allocate public IP. So it is allocated now. Create NAT gateway. NAT gateways. Perfect. Still it is pending state. So NAT gateway is up now. Let me go back to the routing tables. gateway load balancer, endpoint route table, routes, edit routes. And let me add the default route towards NAT gateway. So changes done. So everything is good now. Even on the Palo Alto Firewall, we have policies. Already we have created just health check policy, but it is allowing any traffic anyhow. So we can create another one, but so let it be. Anyhow, it is allowing all the traffics already. So I'm not going to change here anything now. So let me go back to this RDP sessions and let me try to ping this again. Just up arrow. Yeah, it is reachable now. I'm able to ping this google.com. Yeah, that also I'm able to ping. Let me try it again. Guess as this is down, we are unable to see. In google.com, it is working fine now. So let me open browser. This is our test PC. Hope you can observe it clearly. This is our jump host and this is our test PC. Let me type google.com. Okay, let me hit enter and see if it is working. Here I'm facing some issue. Let's see, let's go back to this firewall and see logs. Is here something is coming from the data zone and going to data zone. So let me add some bytes over here. Let me check the 440 traffic is incomplete. However, this is for okay. Let me check this zone first and see the HTTPS traffic. Bytes out and packets received. Send packets received packet output here. But here, see, we don't see any receive packets here. I know the reason. Actually, we did not configure return traffic to pass through this gateway load balancer endpoint. So the forward traffic is going through the firewalls and going back here. So once it is come back to the NAT gateway, it is directly forwarding using this local to this PC. That is the reason we couldn't see any logs. The ping is working, it works because this will not stop exactly like the session is not countable, right? So but in firewall we can see HTTPS traffic sessions. So let me fix this issue and then you can understand clearly. This is like asymmetric routing kind of thing. So let me go back to VPC route tables, and for this particular test 10.10.2.0/24, right? Let me configure this first. NAT routing table routes edit routes 10.10.2.0/24. To reach this network, it should go to gateway load balancer endpoint. This is the one. Just save changes. Let's go back to this page and refresh here. See here, so it is working fine now as expected. Let me go back to this firewall and let's see the traffic now. Packets in, packet received. We can see two ways of traffic. So it is working as expected now. So here is the thing, guys. Finally, we have configured all these things successfully and we are able to test all these things. So thank you for watching. So please subscribe and encourage me to create more videos like this. Thank you. Bye bye.